Alright, what's up? So I'm going to make this video. So this video I'm going to go over coding Tic Tac Toe in Python. So it's just a challenge I set for myself. Really, I just did it last night. And I mean, I did it when I couldn't sleep. And I mean, I just did it. It took me long because I got a little bit stuck on one part, which I'll go over the part that I got stuck on, which took me about like an hour. I got stuck for like an hour. But which made it take, it took probably about 2 hours to do the whole project, which is not good necessarily. Like I got totally stuck, but I ended it. But I finished it, and here I'm going to analyze this, the code and what it does. It's very basic though. I mean, like it's a project I just did in the middle of the night. So basically, what this is going to do is I'm going to show it first off. So let's see. I'll go into Python -i. Tic Tac Toe, run it. So okay, it's pretty basic. So what I did here is it just kind of gives you a little description of what's going on, and it gives you a description of basically how the numbers that correspond to locations on the board. And one thing that I did here is that these locations basically follow the numpad on a keyboard, which I thought that might make sense. But I could have done different. I could have started the one up here. I didn't have to do it like this, but it's just I just chose to do it like this. And then so let's look at what this looks like though. This is so far so bad. So bad. I'm over. Alright, what's going on? So I'm gonna show what I did here. But there's challenges. So I did a challenge last night, where I was like, I'm gonna code up Tic Tac Toe in Python, see how well I can do. And I mean, I was inspired because I know some people have done this on YouTube, like Coding Train, and I also know that there's just so many people who have done Tic Tac Toe in different coding languages. So I was like, okay, let me try doing this. It shouldn't take too long, and it'll probably introduce me some interesting stuff, which I did. So it was a pretty fun project. I did it in probably like less than 2 hours, and I got stuck too on something when I did that. But also I didn't add that many features, so I suppose I could add more features and make it longer. Maybe I'll eventually add some type of AI, maybe like a minimax algorithm or something, and that might be interesting to do. But so basically here, what I did is I'm going to run this program. So I run it here. So this is going to run the tic-tac-toe, that pie. So it has a description. It has I don't know how to say it, like a mapping for each element in the board. So like if you type in a 1, you'll make a move at this bottom left corner. I like that's the best way I can describe this, I think right now. But we can start a game. So it says here, it tells you how to start a game. Just type in start and you can start a game. Now, okay, so the first player is always going to be X, so you can go wherever, but maybe you want to go at 5. Okay. And then maybe you want to go at O. Maybe O wants to go at 8. I don't know. And then maybe X is like, okay, well, let me go at 9. And then O is like, let me go at, well, he's going to want to block X, so he goes here. And then maybe X goes again, and maybe he goes at 3. And then maybe O goes at, I got a little bit too much in here. So I'm going to show a feature too. So let's say O wants to go where it can't go. Let's say I try to go to 9, which X is already there. So I'll just say you can't go there, and it'll give me an option to input it again. Another thing too is if I enter something which doesn't even make sense, it'll tell me that. If I enter something out of the range, it'll tell me that as well. So it's only accepting digits between 1 and 9. So one thing I can do here is maybe go at 7, and then maybe I'll say X will go, well, X is going to win this if I go at, what is it, number 6. So if we go at 6, X just won, so it says player 1 is the winner. You can also get a draw. I can do a draw very easily by just doing 1, 2, 3, or 5, 6. Okay, 9, and to block that, and then 7. Oh shoot, player 1 won. I wasn't even trying to let him win. Okay, try that again. So I want to go, X will go at 2, I guess. O will go at 5. X will then go at 3, and then O is like, oh, I gotta block this. I'll go at 1. Then X is like, okay, I gotta block him, so I'll go to 9. And then O is like, I gotta block him, so I'll go to 6. And then maybe X is like, let me go to 7. And then O is like, well, O is just gonna win, but I'm gonna make sure he doesn't win. I go to 8, and then X goes to, what's my last number? I think that's a 4. So it is a draw. Alright, so those are some of the basic functionalities. I've also just kind of realized something, a feature that I want to add to this. So I'll go over the code and I'm going to add this feature because I just realized it's kind of tedious to have to like go up here and look at this number mapping for what number corresponds to what cell. I guess, is that the best word to describe them as cells? Maybe. Or maybe there's a better word. Wait, what are they? They are blocks? I think they're blocks. So I'll say blocks. So like a number corresponds to a block in a tic-tac-toe board. So one thing I just realized is once you get all the way down here, you've done a couple of games, you're kind of like, oh, okay, well, if I want to check what number corresponds to what block, I got to go up here. So you have to memorize this. I feel like maybe I should add something where it will like show the block to the right after you make a move, or it will show the block, it'll show the mapping block every time. So maybe I'll do that. But first let's go into code that allows the program to do this. So we'll start with really down here. So this is the start thing. This is what I call right at the beginning. So this starts the game. So the first thing I do is I create this thing I call a move map, which is a dictionary, and I index is equal to 1. And so what I do is for I, because of how I have it numbered, which you can see here, like how I have it numbered, well, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. How I have it numbered here, what this means is that when it comes to I is ranging through the rows. I want to kind of go in the reverse direction. I don't want to go from the bottom down. I want to go from the bottom to the top, like, you know, because I want to go from this 1 to the 7. So we start down here. We start at index at 1, and then for J, we're going to go in the normal direction. We're going to go from the left to the right. So I just go from 0 to 3. And basically I take that index and I set it equal to ij. So this is a dictionary, setting the index equal to ij, and then I do index plus or equal to 1. So I go through, I create this mapping, this dictionary that's basically going to have the keys. The keys are going to be the 1, the 2, the 3, and it's going to map to some type of row and column coordinates, so you know where they're on the matrix. So that was the basic idea there. And then here I create basically my empty board, and then I print board. So this is the first function I call. And print board is basically this. It just takes in the row 1, row 2, row 3, and prints them all out on separate lines. So that way it will look like this. And then here I have the board. So then I create the board here with row 1, row 2, row 3. And I'm going to set winner to none. I'm going to say we're at the turns we've done is 0 so far. I'm going to say it's player 1's turn. And then what I did here was, or what's going on here is we have a while loop where basically it's just going to go, it's going to continue looping through until either the winner's not none or until the turns goes above 9. Because once you reach 9 turns, I realize the game is over. I mean, obviously the game is over. I don't know, why would I say that? I don't know why I would say that. Obviously the game is over if you make it to turn 9. The board is full. That was my methodology to keep track of that. There's probably another way to keep track of that as well. But yeah, you could probably do something like say, oh, the board is full. But here what I do is call my first function. So in this while, the first thing we do is the game. And the game takes in the turn, whose turn it is, the board as it is, that mapping of the value to the coordinates of a block, and the number of turns we've done. So it takes in all that, and this function is kind of, is this like the meat of it? It's kind of like the meat of it, isn't it? So what we do here is we're going to run the game. So we're going to get the move, right? So to get the move, that's going to take our user choice. Okay, so we're going to run to that function. And that function is going to do this. It just asks the player to make a valid choice. Is that a good description? I think that's okay. So the move is the input. Anytime you take an input, it's a string. So right now, this is a string. And then I say, while move basically is not a digit, or it's not in the range. Like, it's less than 1 or it's greater than 9. As long as you have that, you're going to print out the statement to give the user some feedback of what it's looking for, and then you update, and it's going to ask for another input, and it's just keep asking for an input until eventually you return an input that is between 1 and 9, and it will return that input. So we get that, and then we go back down the game, so we get that move, and then we get our I and our j coordinates for that move based off of the moves, and the moves here is that mapping. So then once you have that, we want to check that while the board ij is not empty. So this is like if you try to go somewhere that's not empty. You can't go somewhere that is empty. All right, continuing on. I think I'm kind of like getting a little. I think I'm describing too much right now, but okay. I'm gonna try to keep going. I feel like I am describing too much and going maybe in the wrong details, but I'm gonna keep going anyways. So yeah, you print out you can't go there. That's like saying you can't go there, and that's pretty simple. But that's well, what happened like is like you can't go somewhere where someone has already gone. And then we're gonna basically, as long as you keep doing that, it's just gonna keep asking for a new user choice. It's like, give me another user choice. That one didn't work. And we're gonna return the coordinates for each one, and then look at that. Now, if turn is equal to 1, so now finally we get past that while loop, and it's an empty block. So if turn is equal to 1, that means it's the x player's turn. So that means we want to set that board equal to x there. Also, we would set equal to O. Then we're going to increment turns. Really, this is just, it's kind of silly that I created a function to do this. It's really just plus or equal 1. I don't know. I feel like maybe by describing it that way, it describes what it's doing. But yeah, it's literally just incremented by 1. That might be a little bit over the top. Like, I could have just done turns. I could have just done turns plus or equal to 1. I really could have just done that. Why did I not do that? I don't know why I didn't do that. I just feel like I've already done this, and this is not necessarily bad because it kind of describes what the point of it is. Like, each time a player makes a turn, you're going to increment the turns. So you return that, and then the last thing you want to do in the game when you run a game is you want to, after someone makes a move, you want to check winner. So here I have a check winner, and I'll just go over what this does. So like, if the winner is true, you're going to set the winner equals to whose turn it is, and you're going to return that winner. Otherwise, winner will be returned as none. So what does check winner do? I'm going to go over check winner after I go through this. So because check winner is kind of where I got stuck originally. Okay, so we go through this thing, the winner gets returned the turns in the board. So we print out the board to show you how the board looks right after this. You run the game. Then we basically say if it's turn 2, this is turn 2 if turn equals 1. This is I think it's called a ternary operator for an if else. So like, I might be explaining too much here. I don't know what this is even aimed at, but like basically if I did this, turn is equal to 2, else turn is equal to 1. That's basically what that does, but it does it in one line, which is more concise. And I believe these are called ternary operators.